All right, this is Geometry B Unit 4, Lesson 5, Right Triangles and Trigonometry, and we're studying the law of sines and the law of cosines. What this lesson is about really is about solving triangles. That means finding the missing sides and angles. When you have a non-right triangle, a triangle that is not a right triangle. Because if you have a right triangle, use SOHCAHTOA. And if you have a special right triangle with 30, 60, 90 or 45, 45, 90, use those. And if you know two sides and need a third side, use the Pythagorean theorem. But this lesson is particularly for triangles that do not have right angles. That doesn't mean it won't work on right angles, but it's more work than is necessary, and you should just use SOHCAHTOA if you have a right triangle. Okay, that said, there are two formulas you need to be familiar with. One is called the law of sines. There are actually numerous ways to write this, but basically what it says is the side over the sine of the opposite angle is constant. A over sine A equals B over sine B equals C over sine C. Okay? And that's when we have a triangle in this format here. We have a triangle like this, where one side is A, another side is B, another side is C. So we label the vertices with capital letters. Capital A, capital B, capital C. And we put the lowercase letters across from the uppercase letters. So little a is opposite big A, little b is opposite big B, little c is opposite big C. Okay? So that's the way the triangle is organized. So the ratio of the side to its opposite sine, the sine of its opposite angle is the same as constant. That's the law of sines. And then there's the law of cosines, which is a derivative of the Pythagorean theorem. Any side squared equals the other two sides squared and added. Okay, now that would be the Pythagorean theorem if we had it, if we stopped right there. And in fact, if we use a right triangle, if we let angle A be a right angle, the rest of it would be 0. But we have this third factor here, minus 2bc cosine angle A. Because cosine of 90 degrees is actually 0. And this whole thing would drop out if it were a right triangle. Okay, so a squared equals b squared plus c squared, like the Pythagorean theorem, minus 2bc cosine A. Okay, and I'm going to give you a general rule. If you have a side angle pair, so use the law of sines if you have a side angle pair. So if you know capital A and lowercase a, if you know capital B and lowercase b, or capital C and lowercase c, use the law of sines. Otherwise, use the law of cosines. Okay. All right. So let's get into our examples. I'm going to give you 3 examples, and I'm probably going to separate these into multiple videos because they're a little on the long side. So the first example here is I'm gonna do an example of side angle side. No, actually, I'm going to do angle side angle. You recall the triangle congruence theorems. They are side side side, side angle side, angle side angle, angle angle side, and hypotenuse leg. We're not going to deal with the hypotenuse leg. And actually, if you have 2 angles, you have the third angle. So really, these two are kind of a case of the same thing. You can just subtract from 180 to find the third angle. Okay, so if you know 2 angles, you know the third. But I'm going to deal with angle side angle first. So let's set that up. All right, so here we go. We've got a triangle. Got a triangle here. Okay. we're going to draw it like so. And like so. Okay. And we happen to know the length of this side is 15 inches. This angle is 40 degrees, and this angle is 82 degrees. Okay? Actually, let's make it 78 because that looks more like what it is. Okay? And we need to solve the triangle. Solve the triangle means find all the missing sides and angles. Find all the missing sides and angles. That's what solve the triangle means. Okay? So let's label some things here. We have A, B, and C. Now, using the triangle angle sum theorem, I can find the missing angle. The missing angle is 180, take away 40 and 78. 40 and 78 is 118. That leaves 62. Double check. 62 plus 40 is 102. Yep, 180. Good. So that's 62 degrees. And we now have a pair. We know angle C and we know side C. So that means I can use the law of sines because I know a side angle pair. And here's how the law of sines works. So the side, 15, over the sine of its opposite angle, 62, is constant. Now we need to determine what we want to find out. Well, I want to find out what the length of this side is. So that side goes with that, right? So I'm going to actually let's not use x. Let's use a, little a, to be consistent. So little a goes with 40. That pair goes together. So a over sine 40. Okay. So the ratio of the side to the sine of its opposite angle is the same. We have one variable, a, so we're going to cross multiply and divide. Okay? The way I like to do it is this. Multiply the diagonal of variables not on and divide by the remaining side. That's how you solve a proportion. So a equals 15 sine 40 divided by sine 62. Okay? And now it's time to reach for a calculator. So I'm going to reach for Desmos here. There it is. I've got it open. Put some other things on it. Okay. So remember in Desmos, before you use a trig function, click the wrench tool, the settings tool, and choose degrees. Because otherwise your answers won't make sense. But you can enter it just the way it looks right here. 15 sine 40, all divided by sine 62. And we get 10.9 approximately. 10.9, that looks like a 16. 10.9. Okay, so A is approximately 10.9. And always check to make sure it's reasonable. 40 is smaller than 62 and 10.9 is smaller than 15, so it does make sense that it's a little smaller than 15. Okay, now I need to find the third side. We're going to call this little b, right? In fact, let's change colors here and let's say b. Yep, little b goes with capital B, right? And we can set up the law of sines again. So 15 over sine 52, and let's be consistent in the colors here, 15 over sine 62 equals b over sine 78. Okay, equals cross multiply and divide. So I'm going to multiply the diagonal b is not on and divide by the remaining side. So b equals, let's just write it here, b equals 15 sine 78 over sine 62. Okay, is approximately, let's see what we get here, 15 sine 78 over sine 62, 16.6. And that's approximately equal to, and let's check, 16.6 is bigger than 15, but 78 is bigger than 62. So we have solved the triangle. We now know all three angles and all three sides. Okay. All right. I'm going to save the next example or two for the next video.